Gents, easy lesson today. So we're going to look at polygons. You go through a few words, a few kind of terms, prove the formula, very easy. Again, you don't even need to know to prove it, but it's just so easy, I'll show it anyway. And then maybe we'll do one example question, but I think it will be really easy for you. You won't even need me, I can just go away. Just go away. Okay? So, polygon. What is a polygon? Okay? Polygon is a shape, okay? A triangle, a rectangle, a quadrilateral, a pentagon. All these are polygons. Basically, a shape that is, what's the word? It's closed by straight lines. So, what is not a polygon? That is not a polygon. Okay? That's, I don't know, a cloud. Okay? So, all the shapes we'll be working with really are polygons. What is regular polygon? Anyone remembers? You heard it last year? So, a square is a regular. An equilateral triangle is regular polygon. In other words, what is equal? All the sides are equal, also all the angles, but all the sides are equal. So a rectangle, all the angles might be equal, but all the sides are not equal. Right? So that is irregular. A rhombus, very good. Okay? A rhombus is also an irregular object because not all the angles are equal. Okay? So all the sides must be equal and all the angles must be equal. Are we happy with that? So we normally work with 3 sides or 4 sides, but we can work with 5 sides and so on. So we've got bigger polygons. Pentagon, what about 6? What do you call it with 6 sides? Hexagon, 7, I don't know if there's a name. 8? Octagon. 9, I don't know. What's septagon? Maybe. Yeah, probably. Decagon? Decagon is 10 maybe? No big deal. No big deal. Okay? Now comes the more important thing. Okay? What will be the sum of angle of the interior angle in a polygon with n sides? So if you have n sides, what will be the sum of angles? Okay? You might come across that before, and you need to know this formula. It is 180 times n minus 2. So n will be the number of vertices. These are called vertices. The little pointy thing. Watch out when you touch them. It can cut your fingers. Okay? Or the number of sides. The same, right? This one has 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So you minus 2. Well, in this example, it will be 5 minus 2, which is 3, times 180, which is equal to 540. Okay? So that's a formula you need to know. I can give you any number of side, and you can tell me what will be the sum of the internal angles. Just to make sure you know what the internal angles, it's these ones. These are the internal angles, okay? Not the outside. Now, I'm going to very quickly just prove that to you. And there's 2 ways of proving it, okay? I think this is the easiest. So what I'm going to do, I'm going to take the center of our regular polygon, and I'm going to divide it into triangle. Okay? So, if I want to calculate here, sum of internal angles. Right. How many triangles will I have here? 5. In other words, the number of triangles in n polygon will be how many triangles will you have? No, but let's say n, so it will be n triangles. So we're going to have n triangles. What's the sum of angles in a triangle? 180. So the sum of angles in all these triangles is going to be 180 times n. But now that's not the same. Why do I have that minus 2? Anyone can think of a reason? Not sure. Okay, when I added all these angles of these triangles, am I adding things that I shouldn't be adding? The middle bit. The middle bit, that's not internal angles. Only these are the internal angles. So I'm adding these in the middle. How much is all of this? 360. So I need to take minus 360. Taking a common factor, what's a common factor? 180. And in brackets I must write n minus 2. Okay?
Oh, wow.
Okay? So easy. Totally easy, isn't it? 180 n minus 360. We want to take that sum of this 360. Taking 180 as a common factor. 180 minus n minus 2. Right, now we'll take it one step ahead. If this is the sum of, I'm going to get rid of all that. Okay? So now what I've done, I've calculated the sum of the internal angles. Okay? For Pentagon is 540. Now if I have a regular polygon, now what I'm going to do is only for regular polygon. For a regular polygon, what can you tell me about all these angles? They are, for a regular polygon, they are equal. They're all the same, right? So maybe I want to calculate the angle of, or internal angle of a regular polygon. I know that the sum of all the angles together is 180 times n minus 2. What expression could be for the angle, one angle? What do I need to do to that? If the sum of all these angles together is going to be 180 times n minus 2, I want to find out just one angle. Okay, for this is 5. But if it's an n polygon, what do I divide it by? N. Okay? So the two things you need to know from all this story is that the sum of internal angles in an n polygon is 180 times n minus 2. And one angle in a regular polygon, that's only for a regular polygon, because non-regular, irregular have different angles, it's just going to be 180 times n minus 2. Easy or not easy? Pretty easy. Let's look at some questions. So, one example, but before that, again, something they might ask, I'm not sure, I'm just trying to think ahead. So we've got our regular polygon, or any kind of polygon actually, in this case it's a pentagon. Maybe they're going to ask to find what this angle is, call it alpha. Listen, yeah. It's like the center here, imagine the center and line to all the vertices, what would that angle be? Perfect, okay? So if they're asking for that angle in the middle, you're going to basically do 360, which is all those angles, divided by the number of vertices or sides you have. In this case, pentagons of 5. That's another thing they can ask, okay? Okay, so this is question C in exercise 5, page 182. And they're asking you to find, they tell you this is 90, these sides are the same. BDEA is a parallelogram. I think they did tell you that. And they're asked to find out what is X, which is B1. But they're asking you to do it in two ways. The most obvious way is just to look at the triangle, right? BCD. Okay, I know that C is 90. So I know that I'll write it like this. First of all, I would say this. Okay. B1, which is really X, is equal to D1. How do I know that? Okay, so opposite angles.
Is it adjacent sides or opposite?
No, opposite. Oh, sorry. Equal angles opposite equal sides. That's it. Equal angles opposite equal sides. Yeah. Okay? And it's fine if you say slightly different. It's fine. If you say isosceles. Yeah.
It's just fine if you say like opposite angles and then isosceles.
But you need to say it's the opposite the equal sides, because these two angles in isosceles are not equal. So I need to see some way that you know that it's opposite the equal side. Okay, now, so I know this is X. Now I know that X plus, or I'll write it like this, B1 plus D1 plus C is 180. I'm not going to write it, sum of angles in a triangle. Okay, we know that. So we're going to write down 2x plus 90 equal 180. Moving the 90 to this side. We'll do two things at the same time. I think you can figure it out. Move the 90 to this side, so we'll have 90. Divided by 2, x equals 45. End of story, right? But that's the one easy. What's the other way? So the other way, we need to use the fact that I've got a polygon here. Just look at the big shape. A, B, D, C, and B. And in fact, I don't even actually need to do it. Just hang on for a second. Okay, so first thing I've corrected here, thanks to Ollie, that in the diagram, it is clear this line is not an extension, it's a separate line. So we need to look at this whole shape, which has 1, 2, 3, 4, 5 sides. It's a pentagon, but not a regular pentagon. So I will be able to calculate the sum of the angles. Okay, let's just do that for now. Okay, the sum of angles in pentagon will be equal to, what is it? 180 times 5 over 2, 5 minus 2. That's it. And we said it before, it's going to be 540. Now we'll put that on the side. So what I want to do now is find all these angles and add them all up and we'll make an expression, an equation for x, and to say that it's equal to 540, and then we'll find out x. Now, to make things a bit quicker, I'm not going to write all the reason. I'll say it, but I'm not going to write it. How can I find B2? If I know that ABDE is a parallelogram, I know that.
D2 is going to be
120, isn't it? They're co-interior. Okay, so I'm cutting the corners here. I need to say B2 plus A is 180 because they're co-interior, so B2 is 120. Okay? Now, what is D2? 60. What will be the reason? Opposite angle in the parallelogram. Okay? I need to say not just opposite angle in the parallelogram. So D2 equals 60. E will be 120. Okay? Again, opposite angles in the parallelogram. Okay? Now, I've got all the numbers. This I know is already 90, so I'm going to write down. C, 90 plus x plus 60 plus 120 plus 60 plus 120 plus x. I'm adding all these angles. Okay? 90 x plus 60, that's this angle. 120, 60, 120 plus x. All of that is equal 540. Now I'm going to add 90 plus 60, help me out here, 150, 270, 330, 450. 450 plus, don't forget 2x. 2x equal 540. 2x equal 90, x equal 45. Obviously a nasty way of doing it, but they asked for two ways, and then so we use that equation. That was just a way of using that. Okay, that's it guys. Thank you very much.